Question number 6. This question is about hydrogen chloride and hydrochloric acid. Hydrogen chloride is a gas. When this gas is dissolved in water, it is called hydrochloric acid. 6.1 is an AO1 question. Complete the dot and cross diagram to represent the bonding in hydrogen chloride on figure number 7. Use dot and crosses to represent the electrons. You should show only the electrons in the outermost shell. This question is from group 7 elements and covalent bonding. This is hydrogen, this is chlorine, and outermost shells are shown here. We know that electronic configuration of the hydrogen is that it has one electron in the outermost shell, like here. And chlorine belongs to group number 7, and electronic configuration is given here: 17, 2 electrons in the first shell, 8 in the second shell, and 7 in the last shell. Chlorine needs one more electron to become stable because it needs to make 8 electrons in the outermost shell, but there are 7: 1, 2, 3, 4, 5, 6, and 7. Hydrogen needs one electron to become stable because it has one electron in its first shell, so it needs one more electron to make 2 electrons in the outermost shell, and it wants to become as stable as noble gases. Both are non-matters. As the result of that, no one will lose electrons, but they will share the electron. Both will share equal number of electrons. Like hydrogen is coming and bringing its electron. Similarly, chlorine is coming and it bringing one electron for sharing. Out of 7, one electron is shared, and we're going to plot the rest of the electrons here: 1, 2, 3, 4, 5, and 6. Let's count the number of electrons for hydrogen: 1, and the shared one, 2 electrons. For chlorine, 1, 2, 3, 4, 5, 6, and shared pair also 7 and 8. Students sometimes make a mistake. They try to mention only this bond here, but they usually forget to mention the rest of the electrons in chlorine, and they lose 1 mark. 6.2 is an AO2 question. It is an application based question. The student need to apply their knowledge. Hydrogen chloride dissolves in water to produce hydrochloric acid. So when we take HCl gas, when it dissolves in the water, the solution is called hydrochloric acid. Hydrochloric acid is a strong acid. What is meant by the term strong acid? This question is from the concept of the strong and weak acids. Let's see the model answer. A strong acid is an acid which completely ionizes in the aqueous solution, like HCl. When HCl is dissolved in water, it splits up into H plus and Cl negative fully. On the other hand, we have an acetic acid, CH3COOH. It has 4 hydrogen atoms present here. When it is dissolved in the water, out of the 4 hydrogen, it just liberates only 1 hydrogen. And we can see here rest of the hydrogen are remain there, CH3COO minus, and releases only 1 hydrogen. So out of 4 hydrogen, 1 hydrogen is released in the solution. On the other hand, in the case of HCl, it has only 1 hydrogen. On dissolving in water, it releases 1 hydrogen ion there. It fully dissociates into H plus and Cl negative, whereas in his case there is still containing 3 hydrogen and only dissociate with 1 hydrogen ion. 6.3 again is an AO3 question, and this question is from the topic of concept of strong and weak acids. Describe how magnesium can be used to distinguish between a strong and a weak acid of the same concentration. If we have the same concentration of the strong acid or a weak acid, we are going to use magnesium metal. When magnesium metal is added in strong acid, the rate of the reaction is very fast. A lot of fusing of the gas will take place, and the reaction is taken place at the high rate, and magnesium will disappear very quickly. If the magnesium with the same size is added in the same concentration of a weak acid, then the bubble of the gas will form slowly, the rate of reaction is slow, and magnesium will disappear slowly in the weak acid. Let's see the model answer. When magnesium is added in the strong acid, a lot of fusing of the gas or the bubbles will form. Magnesium will disappear at a greater rate with a strong acid. Or the student can write the other way around with the weak acid. When magnesium is added in a weak acid, less bubbles of the gas will form. Magnesium will disappear slowly within a weak acid. The student can use for the strong acid or they can use it for the weak acid. 6.4. The concentration of the hydrochloric acid is increased by a factor of 100. What is the change in pH? It is an AO1 question, and this question is from the topic of strong and weak acids. We need to create a relation between the concentration and the pH. If the concentration changes by a factor of 10, the pH changes by a factor of 1. If the concentration is 100, 100 means 10 times 10, the pH changes by a factor of 2. 1 plus 1, that is 2. If we have the concentration 1000, it means we can write 1000 as 10 into 10 into 10. The pH changes by a factor of 3. For each 10, the change is 1 plus 1 plus 1 is equal to 3. In our question, the concentration changes by a factor of 100. It means that the pH will decrease by the unit of 2. Let's see the model answer. As the concentration increases by a factor of 100, the pH will decrease by unit 2. This means this is more acidic solution. 6.5 is a NO2 question. Ethene and hydrogen chloride react to produce chloroethane. We have display formula like ethene plus hydrogen chloride HCl. They react together and they form chloroethane. These are my reactants. These are my products. The reaction is an exothermic, so it is the key information. So energy is released from inside the reaction to the surrounding. In the reaction, the energy released from the new bond is 56 kilojoules per mole greater than the energy needed to break the existing bond. In table number 1, the bond energies are present. Calculate the bond energy X. And this X is actually present here in the reactant side. This energy X is present in the reactant sides. So if we know the energies of the reactants and we know the energy of the products, then we can find the energy which is present between the carbon-carbon atoms. Let's see the model answer. The easy thing for the student is to remember the energy of the reactants is equal to energy of the products plus the energy released. It is an exothermic reaction, therefore energy released will be taken as negative. So we are going to make our reaction very clear. Let's take the energy of the reactants. We can see here on the left side the bonds between carbon and hydrogen. There are four bonds, 1, 2, 3, and 4. And energy between hydrogen and carbon is 413. So 4 times into 413 plus there is one double bond is present, which is our X. So 1 into X plus there is a bond between hydrogen and chlorine, that is given 431 plus one bond into 431. So altogether it is X plus 2083. On the right side we have the product which is called chloroethane. We have different kinds of the bonds present here, 1, 2, 3, 4, and 5. There are 5 bonds present between hydrogen and carbon. So 5 times into the energy of hydrogen and carbon plus there is a bond present between carbon and carbon, 1 into 346. This is the bond energy present between carbon and carbon plus there is one bond present between carbon and chlorine plus 1 into the bond energy present between carbon and chlorine, 339. And we get like 2750. We need to use these values here in this equation or in this equation. Both equations are valid. If we use here, so energy of the reactants, that is X plus 2083. So we can use this thing here, X plus 2083 plus energy of the products, that is 2750, because it is an exothermic reaction, therefore energy is released into the environment. So energy is going from inside to outside. There is a loss of energy and the loss of energy is used as negative energy. Then X is equal to 2750 minus 56 minus 2083, and the answer is 611 is the bond energy present between the carbon-carbon atom. Or you can use the other way around here. The energy released is equal to energy of the products minus energy of the reactants. It's the same formula. If we use this formula, we can write in this way. The answer is 611 kilojoules per mole of energy. This energy is present between the carbon-carbon atom.